Iron, let's see how we can make our image detection project. So like image or color detection project. So as you can see, I've got a red color box. So leaving this red color box, you can't see anything else, right? Everything else is black and leaving this red color box. So yeah, we'll be making this project today. So let's start with this code. So before that, we will make our a simple we'll make a simple project, right? So logic for that project could be so right. So let's say this my box, right, with some colors white, red, violet, blue, green. This B1, and bit is a box with container. What if I do bitwise AND? So AND will only give us true whenever it will get something common. Since if I need red, I will do bitwise with red and I will get red as output. So this my logic false project. So let's see how we can do it. Uh, yeah. So oh, sorry, this my VS code. So before doing this project, what I will do, I will take a image. Let's say that is balls image, and I will detect any color that is either blue, yellow, violet, uh, mm, green, yeah, or any, right? So first we'll do color balls detection, balls detection. Sorry. So to do so, we need Opencv. So first I will import my Opencv, import cv2 as cv, import numpy as numpy. So to show that particular image, I will use img is equal to cv.im read and we'll pass the mm, box dot jpg address, right? And I will pass my true to show that image, right? And to show that image, I will use cv.im show. Sorry, I am show pass img comma img. And right now I'll write my if condition to terminate that following window that will get opened, right? So cv dot wait key that is one. Or why I'm passing cv dot wait key. Why I'm passing one, since one stands for infinite loop here, and it takes input as millisecond, but for one it's infinite, right? And I will put our mask 0xff is equal to ordq. Ord is a keyword function. Like if you press Q in your keyboard, this if condition will get terminated and the following loop will end. Once loop is end, we will destroy all windows, right? It means whenever we press Q, if will get executed, loop will get break, and the following window that will get destroyed. I will show you what that window stand. So sorry, let me end this rescue. Yeah. So this is my image, right? So once I press Q, this window will get destroyed, right? This window will get destroyed. So I already told you what logic we'll be using. We'll do bitwise and we'll create this image. We'll create this image. We'll do bitwise and right. We'll do bitwise and of those images. So if I need to detect blue color, right? So to do so, we need its lower bound value and uh, upper bound upper bound value, and to perform this box detection or color color detection, we will be using a HSV model, right? So HSV model stands for hue, saturation, satu, uh, saturation, and we stand for value, right? So Let's see how we can make a color. Since by default this OpenCV model works on a BGR color, so to work upon this HSV color model, we need to convert it. So HSV is equal to CV dot convert color. We'll pass our IMG and we'll pass our CV dot color BGR to HSV. Right. This is my HSV. Now I need my lower bound and upper bound. Why I need a lower bound? For masking, like for masking. I will tell you what masking is. So we will use our mask equal to CB dot in range is a function to apply this masking. It will take HSV. It will take two value, lower bound of that color and upper bound of that color. So to decide lower bound of that color, we'll use a color picker, right? So this is my upper bound. So let's pass our upper bound 250, 75, 42. Since our model works on PGR, so we need to pass value from descending right, like 250, 76, sorry, 72, 77, and 40, not 42, 77, 250. I guess you understand this. So we'll pass our that color, we'll pass our lower lower V, right? Lower value. We'll use our I will pass that following value in an array and array and that value is 250 comma 77 comma 42 my lower and we need now upper value to np dot array. This is my sorry, this was my upper value. Oh, sorry, upper, and now I need to pass my lower and this one is my lower value, that is 122 122 comma 24 comma 5. So right, I will pass this lower v and I'll pass my upper v, right? And now I will do my bitwise or filtering thing. So let's name is frame cv dot bitwise and img means that this whole box. Again I will pass img means this. I'll like suppose I'm passing this red color, and when I am passing this red color, I need to or capture my mask. So I'll pass mask equal to mask. And now I need to show them cv dot I am show frame comma frame. I will show my mask too. So cv dot I am show mask sorry mask comma mask. Right. So let's see what output we get. So this is my image and yeah, I think we need to correct our values. So mm, let's change our values. Let's see what all type of color. Like let's detect yellow color, right? Better detect yellow color. So we're choosing yellow. So upper bound is 54 to 38 and 245. 58 to 38 and 230 45. Right? This is my upper bound. And my lower bound is uh, 13, 138, 13, 138, comma 143. Let's see if this works. 143. I need to end this rescue so the whole window will get destroyed. And right, so this is my image. I wrote the pixel values for this yellow, and this my pixel value. So some of the greenish color. So that ignore this, right? And this my mask. So let me explain the code. What I did, I wrote my pixels for yellow color, and then I converted that in my mask. Mask is detect that yellow. Some greenish part is also there, but still we can improve that pixels and remove those value. And then I then did this bitwise. What I did bitwise, I have performed this logic. Yeah. So this could work for an image, but what if I wanna use this whole model for a video capture, right? So let's write that code. So we'll write object, not we'll write color dot py name of the file, right? We'll use our Opencv import CV2 as CV, and we will use we'll use numpy also, sorry. Wait, import numpy as npy. Since we are writing here those value, so to avoid this we're using track bars. So 1, 2, 3, 4, 5, 6 values are there, so we need 6 track bars. So we need 6 track bar of those value, right? Mm, we need 6 track bars, and then we'll use same logic here also. First, write the logic for video, right? So we will use cap equal to cv dot video capture. Will pass 0. 0 is a default index of your camera. So to check that that particular camera is working or not, use cap dot is capital O open. If this gives you true value, means your camera index at is 0 is true. So let us see. First, let me end this window, press Q. So, so we got our value true, means our index is correct, right? So I'll use this value since cap dot open is correct. So our while we will run infinitely, and to store that frame that we get from here, we'll use ret comma frame equal to cap dot read, right? Ret show true value and frame show that frame, right? So we'll put if ret means, if ret is true or false, means it has captured those frame, means that frame is active, right? When our frame is active, I will show that following frame. CV dot I am show frame comma frame, right? And now I will write my logic for the frame, that CV dot wait one, and we'll do masking. So 0x ff equal to ord. When I press my Q, my window will get end. So window will pass Q break. And if my red is false, means my window is not active, at that condition, just break it, right? Once you break the following loop, you need to release that cap, right? And to destroy that window. So you don't destroy all windows. So let's say our webcam logic works fine, like video capturing logic. Yeah, so our video capture is working fine, right? Now, as I said, we need this 1, 2, 3, 4, 5, 6 values to choose any color, right? And the color you can choose from this color picker app. So now we need our track bars. We need our track bars, right? So before that track bar, we need to name a window. So cv dot named window, right? We'll put that name as image, right? Now let's create our track bar. Cv dot create uh, create track bar. The first is track bar name. So what we can pass, this is HSV, HSV. So this my lower HSV, this my lower, sorry, this my lower H, this my lower S, this my lower V, this is my upper S, this is my upper S, upper V. So we need to make six track bars. So first let me pass low H, right? Then we'll pass window name. The window name's image, as I mentioned above, image. Then it will take uh, the count means the index from where you want to start that following track bars. So all the values start from 0 and with 255. So 0 comma 255, and it take a callback function. Let's name is nothing, right? And let's define that function. We'll use def nothing self, and we'll pass this function. We won't do anything, right? So this is my logic for S. We need six more, three, four, five, six, right? This my low S, this my low S, this my low V, and instead of low, now we need our uh, upper S, upper V, and we won't pass from 0. Instead, we'll pass from 2, 5, 5, 2, 5, 5, 2, 5, 5. When I wrote 0, comma 255 means it will start from 0 and with 255, and when I wrote 255 comma 255 means it will start from, sorry, it will start from 255 and end to 0, right? This will work from left to right, the first three, and first four will work from right to left. So let's see how our track bar looks. So this is my track bar, and this is my webcam frame. So anything won't happen since we didn't write any logic for this. Let's write the logic, right? So we'll write our logic here when our frame is active, right? Since you've created these track bars as I showed you, now we need to access those values. So to access those value, we need to pass low h cv dot get track position. We'll pass name of that following h, and the window name, that is image. Why window is image? Since we have called that cv.name window is image. Now this is my first value. I need five more. Why five more? As I said, our track bar contain six things: low s, low v, high h, high v, and sorry, high h, high s, and high v. Right? So to access, now I'll copy. Sorry, I'll copy this. Control V. mm, Control V. Control V. Control V. Yeah, this is my low H. This is my low S. This is my low V. S V. And this is my upper H. Upper S. Upper V. I am going to change this name to upper S. Upper S. And upper V. Right? Now we got what value we got? We got this value, low S, low H, low S, low V, upper H, upper V, upper S, upper V, right? So we got those value. Now, since we got those value, So what you can do is we can put in lower bound and upper bound. So what we need to create is create a upper bound, upper bound, put them in array as we did earlier. So upper bound first value is upper h, upper s, upper v, right? As we did here, where we just passed upper values. Same we will do our lower bound, lower bound, that is np dot array, and we'll pass our low low h, low s, low s, comma low v. Now we need our conversion, right? To convert my BGR to HSV. So we'll use HSV CV dot convert color. We will pass our frame, or frame rate. We will pass our frame CV dot color, uh, color BGR to HSV. Right now we need to create our mask. So mask equal to CV dot in range. We'll pass our HSV. We'll pass two value, lower bound and upper bound. Lower bound, lower bound, and upper bound. Now I need to create my filter, comma bitwise, right? I just use the same logic that I've done before. So we'll name it that as frame CV dot bitwise and frame, comma mask, right? Now I will show that frame also. I will show our mask CV dot. Let's name is frame one. So CV dot will show our mask also. CV dot I am show uh, mask MSK, right? Same name for better results, and we'll show this frame also that we got after bitwise. CV dot I am show frame one, comma frame one, right? So let's see everything goes well. So this is my track bar. Uh, Wait, yeah. Now this is my track bar. Mm, Anything wrong? 42, line number 42. Sorry. And anything else? Oh, now let's see. Mm, yeah. So this is my frame, and this. Let me put my mask here. This is my mask, right? Now, if I increase my values to 4, let's decrease this, and this one, uh, and wait a second, that's not working. Mm, Wait, well, I don't need this value. C dot wait break. I think I need to put my HSV. Yes, HSV should be here. Yes, I think now code will work. Mm, our mouse is working fine, like, mm, but our frame is not working. Uh, let's see what we did wrong. Upper H, upper H, uh, low S, low S. I should write same name. Upper H, upper S, image. Oh, we didn't add our mask, right? Yeah. And now our code will work. Fine. Yeah. So this is my track bar, and this is my frame, and this, the following is my mask. So, yeah. So let me include my value. Um, mm, yeah, yeah, you can see, like, if I add more saturation comma value. So for this value, our project can identify this red color box और बाकी को इसने black कर दिया, right? From the logic of bitwise and yeah. So if I take this red, anything else won't be visible to you, right? So you can help choose the better values for better result, but this project seems good to me. Yeah. So yeah, this is the logic you use for color detection. So thank you.